Hi, this is Leetcode question, smallest sufficient team. In this example, the answer is 02. We will use dynamic programming to solve this question, and to do that, the first thing is to create a dictionary that maps each skill to its index. So this skill is at index 0. This skill is at index 1. This skill is at index 2. And after the for loop, indexes dictionary will have Java at 0, Node JS at 1, React JS at 2. Then in this loop we create another dictionary that map every person into a mask that represent his skills. So here we have three skills. So the mask will have max 3 bits. For example, here we have this person has Node.js and React.js. Node.js is at bit 0, bit 1, and React.js is at bit 2. He doesn't have Java skill, so it will be 0. So 1, 1, 0, his mask is 6. And this person has skill Node.js only, which is at bit 1. At bit 0 he has he doesn't have this skill, and bit 2 he doesn't have this skill, so at the end the mask is 2. So after this loop, the masks dictionary contains this value. Person 0 has the mask Java, which is 1. Person 1 has this skill, and it's 1, 0 in binary is 2. Person 2 has this mask. So from this mask we can know which skill he has, because 6 in binary is 1, 1, 0. So, and we know bit 0 and bit 1, or bit 1 and bit 2 represents these two skills. After that, we create a table of length equal 2 to the power n. So p equal 2 to the power n is the size of the skills. Here we have 3 skills and equal 8. So we have table of size 8. Zero, 1, 2, 3, 4, 5, 6, 7. The index itself represents the skill set, or the masks that represent the skill set. For example, if we take this 3 is 1, 1, 0 in binary. That means these 2 bits are set, and these 2 bits represent the first and the second bits, Java and Node.js. And the value is a vector that represents the number or the people that can form this skill, or the minimum number of people that can create this skill set, and initially we fill every person skill set to its index. So the first person I0 has masks of I equal 1. So this is a skill set. TB of 1 contains person 1 0. That means this person can create this skill set. Then second person 1 has this skill set. So TB of 2 contains second person. TB of 6 contains the last person. That means this group of people can create this skill set. Then we iterate over all person, and for every person we iterate over all the skill set. And in order to or the idea is so this person, the current person, has specific skill set, which is masks of I. Masks of I represents the current person skill set. Now we need to join this skill set with current J. So we said these are skill set, and we see that if after joining the person skill set with this skill set, it will form a new skill set called combination. So mask of I or J, this will equal combination, which is the new skill set. Now we need to check the new skill set combination. If it's empty, that means we have to assign whatever the results in J, whatever the current result in J plus the current person, because this new combination is formed by the group at J and the current person. If it's not empty, we need to check if this give us better answer than whatever is stored here. So if the group at J plus the current person has size smaller than the group stored at this combination, we update this by the group of J and the current person. If not, we don't do anything. Notice that to move from or to do this calculation, the current J should have a group of people to form it, because there is no point, for example, if this group or this skill set is empty, we cannot do this operation, because this group or this skill set cannot be formed by an empty people. This is why here we check that TB of J must have a group of people, and here again we check our condition. As we said, if combination TB of combination is empty, we need to assign, or if it has its size is greater than the size of people created by this mask. So let's see how this works. We start with the first person 0, so I equal 0, and masks of 0 is 1, masks of I equal 1. Now we need to iterate over all j's. This is empty, so we skip it. This has group of 0, so we do the OR. 1 or, which is masks of I, or the current value is 1 equal 1, and at the end this condition here, TB of 1 will not apply, because TB of 1 plus 1 is greater than TB of 1. Then we go to this index J2, J equal 2, and the mask is 1. 2 or 1 equal 3. Now TB of 3 is empty, so directly we assign it the group at J. What was the group at J? It's 1, and we assign to it the current person 0. That means this group 1 0 can create this skill set. Then we move to 3 J, so J is at 3 now. Now 3 or 1 is equal 3, so it will point to the same cell, and at the end this condition will not apply. Then we move to J equal 4, 4 or 1, this equal, so 4 in binary is 1 0 0, and 1 in binary is 0 0 1. If we do ORing, the answer will be 5. 5 is empty, so directly we fill it with the current solution at 3 1 0, and the current I, which is 0. But 1 second, we said that if TB of J is empty, we will not do anything, so J here is empty. Actually we should skip this. Then J is 5, 5 is 1, or we said we skipped it from the previous, because we filled this because of 4, so 5 is empty, we skip it. 6, now 6 has 2, 6 or 1 equal 7. TB of 7 is empty, so we fill it with TB of J and the current person. That means these two persons can create this skill set. We are done from the first person. Then we move to I equal 1 with masks of I equal 2. This is empty, we skip it. This is 0, so 1, which is the skill set, and the skill set from the current person is 2. 1 or 2 equal 3. Now TB3 has two persons, and if you want to use this, in 1 we has one person, 1 plus the current person, which is I equal 1 equal 2. So there will be two persons to create this mask, and it's the same answer on TB of 2, so this condition will not apply. Then this is J, then we move J to equal 2, Now 2 or the current mask is 2 equal 2, it will be the same, and we will not, at the end we will have the same answer here. Then j equal 3 or 2 equal 3. So we are pointing to the same element. At the end, this condition will not apply because TP, the size at the 3 is 2 plus the current person equal 3. 3 is greater than 2, so nothing will happen. Then j is here, this is empty. Then j is here, this is empty. Then j is here, 2. Now 6 or 2, this equal 6. Again, we'll point to the same element, so it will, at the end we will have the same result. Then j equals 7. 7 or 2 equal 7, and we will still have this group. Then we move to the last person. I equal 2, masks of I equal 6. J is here, this is empty. J is here, 0. 1 or 6, 1 or 6 equal 7. Now what is the result at 1 is this person with size equal 1 plus the current person equal 2. 2 is not greater than the answer is, or not smaller than the answer at 7, so we will not update the value at 7. Then j is here with the value 1. 1 or 6, or here 2, the skill set 2 or 6 equal 6. What is the value at 6? We have 1 person, and here we have 1 person. 1 plus 1 is 2, is greater than 2, so we will not update the value at 6. 3, 1, 0, the mask 3 or 2 equal 3 or 2. 3 is 1, 1, 2 is 1, 0, this is 1, 1, so 3 or 2 is 3. It will point to the same cell and we will not update. 4 is empty, 5 is empty, 6 has 1 person. 6 or 2 equal 6, because 6 is 1, 1, 0 and 2 is 1, 0, so it will be 6, and it will point to the same element in the current j, and at the end we'll have the same answer. 7 or 2 equal 7. Again, we'll have the current answer, and at the end we return the last value that has this skill set, because this skill set 7 has all the bits set to 1, and we need the minimum number of people that can create this skill set, so we return the last element in the table, and in this case the answer will be 2, 0 or 0, 2. Now time complexity for this, we have p 2 to the power n. If n is the size of skills multiplied by m, m is the number of people.